Before I forget, sometimes I have this Alzheimer's come and hit me in the head, and I forget to let you know that to keep your questions till the end of the presentation, okay? And I'll try to answer them in real time. If I can't answer it because maybe it's a long answer, I'll put it down in the description, in the comments section, and I'll address it next week or during the week. Okay, what are we going to talk about today? We're going to talk about the blocked universe, whatever that is. It's got a lot to do with time, by the way. And before we can get to that, I'm going to talk about this fellow. We have a clown that's come over and for a couple of weeks now, and he criticizes what we do here, and that's his job, I guess. Any critic is welcome here. The issue is that he criticizes it from the point of view of the mathematical establishment. And that's good. That's really good because what it shows is exactly how these people think or don't. And I have a problem with the way they think. It's not thinking at all. It's irrational completely. And specifically where these people fail is in definitions. They never defined words in the last 10,000 years. The key words that we need to do physics, which is rational explanations of mechanisms and causes and so on. And so the issue is they never defined words. This fellow is now improvising. He says, I got to define some words here. Okay, let's see. And so he's an amateur at doing this. Maybe he stayed one night and said, well, let's see, I'm going to put this definition for this one for that. Looked up a couple of them, and that's what he wrote down, okay, to me. So let's look at these definitions, especially today. It's going to be a definitions lecture, the first part, right? And I want you to focus on how a mathematician thinks, because he essentially, I don't know if he's a mathematician, but he represents the mathematical establishment in the way he processes things in his mind, in his clown mind, because I treat them as clowns. I have to believe that they're joking. I can't take them seriously. So let's find out how these people think, how they define words especially, okay? And yeah, you do need to define words if you're going to be doing physics, science, right? Because otherwise, what are you saying? If you say X and then you mention Y and then you go there and say Z and you never define these words, these terms, right? What are you saying? What's coming out of your mouth? Are we all hearing the same thing? And so, yeah, definitions are extremely, extremely important in science and in physics, especially, right? If you're going to give a physical interpretation. And so, this fellow wants to unite math with physics, and that can't be. You can never unite math with physics. These are two different things. Math is a language which has no definitions, by the way, not a single one, okay? It's a language of tautologies, of adverbs, of dynamic adverbs. That's all it is. Okay, there are no adjectives. They don't really care. I mean, they do talk about the dead cat and the live cat, but again, dead and alive are, dynamic words. So there are no adjectives. The mathematician doesn't care about black or white or chair or anything like that, and they don't care about chairs or tables or rocks or trees. They don't care about objects. They don't care about adjectives that qualify or modify objects. All they care about is dynamic adverbs. How something moves, that's what they're going to describe, not explain, describe. And so they have no explanations. All they have is a language of descriptions, which is conveyed through adverbs. Okay? And so that's what they have. And so when this fellow tries to give it his amateurish attempt at defining key words, he thinks I pulled these words out of my mind somewhere, like not important, but let's answer some of these words. Let's define them. And so he does a terrible job. What can I say? Okay, so here it goes. Here we have our clown, and he's going to be defining some terms that we believe are crucial in physics. You can't do physics without them. I put out a list of them last week. I call them the foundations of physics. They include words such as object. You need to have an object to do physics. You can't do physics without objects. If there were nothing in the universe, there would be no physics happening, right? So you need objects. You need words such as distance between objects. You need words such as location, motion, existence. Physics is the science of existence. You need to know the difference between an object and a concept. You need to know the difference between a thing and nothing, meaning a thing being an object, nothing being space, vacuum, right? Nothingness, that's nothing. So we need to know all these words before we can talk about, physics. And not a single word of these has ever been defined in any textbook of physics. You won't find them there. And so you say, well, how can this be a textbook of physics if none of these words, which are necessary to explain physics, are in there, defined, or even mentioned? Well, they're mentioned. They always use these words. They invoke these words constantly. They talk about objects, they talk about existence, they talk about location and distance and so on. But they never defined them. Never have they defined them, and they never defined them specifically in a scientific matter. And so this guy's going to give it his amateurish first try. He never defined a word in his life, obviously. And now he's going to give it a try. So let's have a good laugh at this clown. He's a clown, no doubt about it. Here goes. Okay, let's start with this one. It's going to be the... he calls it physics. No, it's mathematics. So he says, modern mathematics, what we can measure, yeah, maybe that's what they do in mathematics. They model, but only with concepts. They never model with objects, okay? So they do not simulate with objects. They do it only with concepts. And for that, you need to know the difference between an object and a concept, which obviously he doesn't. And then he tests. He carries out some tests, some experiment out there, right? So that's what he thinks is the core of mathematics. And he says everything ties to measurement. Okay, so it's what you can measure. And he's going to emphasize throughout his dissertation these two words, measurement and observation. So keep those two words in mind. We're going to be talking a lot about them. And here it says, replace physics requires objects. He says you got to replace that with what? Physics requires observables. Okay, and those are connected by mathematical relationships. So here we have observables, which is a concept, and he's going to connect them with mathematics of some kind, or some kind of relationship. Okay, but the important thing is he says it doesn't require objects. He doesn't want objects in there because he's not going to do his physics with objects. But then the first thing he says is, this accommodates objects. I love that. He's got these contradictions. He lives with them. He goes right through them. He doesn't even notice it. It just goes from one ear to the other, one eye to the other. He doesn't see this. Fields and space-time. What is fields? Well, it's a bunch of lines, actually a bunch of numbers. That's how it's defined. But they don't know what a field is. It's a region that, what's his name? Faraday defined. Okay, he says it's a region of space where something happens. That's essentially his notion of field. And these people say, well, what we do in that space, we give numbers to the different locations because we're interested in measuring. Okay, there's nothing to observe. There's just measurements. And so they take measurements of different kinds, whether it's magnetism or electricity or gravity, right? And so they create this field of numbers. That's what it is. Then he's got space-time. What is space-time? Well, it's those number lines that you see there. They replace that, or they pictorially represent them with this fishnet. And they say, okay, we got away with it. So they put a physical thing to replace the numbers of physics, which are number lines. So what you're staring at there is bent, warped, right? Number lines. So that you're looking at a net, and you think you're saying, okay, I understand what a net is. Yeah, but that's not what you're staring at, because that's a pictorial representation of number lines, of numbers. Okay. Okay, he says this accommodates objects, which is really, he's talking about concepts. He's not talking about objects at all. And it says, and matches how physics is actually done. What is he talking about? Well, he's talking about this is the way we do it, and we're not going to change it. He's talking about tradition, authority, democracy. This is how we've always done it. We're not going to change anything, right? This is what we call physics. And, he's got no monopoly over the word physics. In fact, the word physics was defined originally by Aristotle 2,000 years ago, right? And these people 400 years ago changed the notion of physics that Aristotle had. There's no reason why we can't change it today if it's still undefined or misdefined or wrongfully, irrationally defined. Okay, he says physics. What is physics? What he calls physics, right? It's a systematic study, systematic investigation. See, I beat him up so much on the word study. He doesn't want to use the word study, so he replaced it with the word investigation, which is a synonym. It's the same thing. Whether you study or you investigate, that doesn't make you a physicist. In other words, you have a 5-year-old child, and he goes in there, and what does he do? Well, the child goes in there and reads a book. He's studying. He's investigating. Does that make him a physicist because he's studying or investigating? So no, the word study or investigation should never be used to define any discipline, any scientific discipline, okay? He says of nature. Well, nature, what are we talking about? Nature's pretty big, Is he talking about homosexuality? Is he talking about sex? Is this part of what he's talking? He's talking about intelligence. Are those subject matters of physics? How someone behaved the other day, he killed someone. Does that, do we have to investigate his mind and find out why he did that? Is that part of physics? And so nature's pretty big. Nature's a bad word to use there. And once he's going to do it, he's going to do it via observation. Well, what are you going to observe for gravity? The pencil falls downwards, and can you see the mediator that came in contact with a pencil when it fell to the floor? And if you can, what are you observing? There's nothing to observe if it's an invisible, intangible entity. You're going to spend all day long. In fact, 10,000 years now they've been observing, and they've never figured out, because observation's not going to tell them what they're seeking. They're asking a question, what caused it? And for that, you need to identify the invisible, intangible objects that Mother Nature uses. And observation, meaning eyes, are not going to help you at all. And then he puts in there other stuff that's got nothing to do with physics. Quantification, modeling, again, with concepts. Experimental testing. What are you going to test? You want to drop the pencil 10 more times, and that's going to tell you what gravity is. To uncover what? Patterns, laws, and he puts explanations, but I corrected him. No, in all of physics, there are mathematics, right? Mathematical physics. In all of mathematics, there are no explanations. All of them are descriptions. And here, let me prove that to you. I like to make sure that everybody is convinced. And here we have a clown from university. What is it? Lock Haven University in Pennsylvania. He's emeritus and physics, mathematics. What did he say? Science, in other words, mathematics, doesn't explain. Mathematics describes. Okay, that's what he says. So yeah, any person talking about explanation has no idea what he's talking about. Not in mathematics. There are no explanations emanating from mathematics. All you have to explain is why this pencil falls downwards. That's how simple it is. That's an explanation, a physical interpretation for why, what causes this to fall downwards. The only way you're going to explain it is by identifying the invisible mediators that come in contact with the pencil. Then you can explain it. Then you can make a movie of it, show it to people, and people say, oh, I understand what mechanism you propose. Okay, like in our case, we propose that each atom of the pencil is bound to every atom on Earth, okay? And that had better be true, because that's how we run our, all our rockets to outer space. They work with Newton's equation, which is mass times mass divided by distance squared. And hopefully, mass times mass means that every mass, every atom of this pulls on every atom of the earth, mass times mass, right? And every atom of earth is physically connected to every atom of the pen. So you had better draw something down here, Now, some people want to do it with push gravity, and good luck with that. Okay, so what's the big problem? The big problem with this fellow, he doesn't know what an object is, what a thing is. No mathematician knows what a thing is. They cannot understand. They've never defined the word object, what a thing is, and so they don't understand what a thing is. And that's why they keep using concepts as physical objects, mistaking them for physical objects. And what they're doing is reifying concepts and then moving the concept around. And so this is what he's going to say. He says, what counts as physically real? No, physical and real are two different things. Either you talk about objects, which is what physical is, or you talk about existence, which is something a little bit different than just physical. Okay, but he says physical entity has measurable properties. That's what he thinks it is. It's something that has measurable properties. Participates in interactions. Okay, so he says, one object interacts with another, I guess. That's what he's saying. They bump each other, or somehow from a distance they pull on each other. Carries energy and momentum. What the hell is energy? Energy has never been defined. He says it carries energy. How do you carry a concept? How do you carry momentum? How do you carry a concept? These people are carrying concepts around, and you can see how they reify these concepts. They say, look, energy, which is a concept, he's carrying it. And same with momentum. How do you carry momentum? I mean, what kind of language is that? And then he continues, says, and stands in spatio-temporal relations. He has to put his space-time in there. That's why he defined it that way. But look at what he does for object, which I don't know what the difference is between an object and a physical entity, but apparently he thinks there's a difference. And he says, bounded in space. Well, that sounds like the scientific definition, which is that which has shape. Why would he say bounded in space? I mean, that's a weird way of saying shape, it seems to me at least, right? And, bounded is a field of physical object, which he's going to say it is. He says physical entities down there is a field is a physical entity. And, it's not bounded in space because all fields are infinite. But he never realized that. So it's not bounded, it's unbounded. So, again, he's saying that a field is not an object, it's not a thing. Okay? Same for space-time. Space-time really is fields. It's a field theory, right? And so you have this ridiculous net that the relativists draw, and then they tell you to forget it. It says, well, you're taking it too seriously. You're taking it too literally. Well, that's what I see in front of me. Objectively, I see a net. So if you didn't mean a net, why did you put a net there to represent number lines? That's the issue. And then you warp them. You warp the number lines. You warp the numbers. So he says physical properties, and he mentions mass, charge, temperature, and energy. I don't know why he puts the word physical. What's it got to do with physical? These are just properties, attributes. That's all it is. They're concepts. They have nothing to do with physical. Physical are rocks, trees, houses, tables, chairs. Those are physical. So the physical entity and physical properties, he tries to put them together as a single thing. That's what he's trying to get away with. And, of course, we won't let him. Includes objects. And what are objects? Well, he's got some examples there. Yeah, electrons, atoms are probably objects, right? But then he says entities, electromagnetic, gravitational, quantum fields. Entities are fields. So are fields the same thing as objects? Are they things? I mean, what's the difference between an entity and an object? That's what he's got to specify. And then he's got there, it says space-time. He said geometric structure. Is it a structure? Is space-time a structure? Again, he thinks that net is a structure. And that's why he curves it. But it's not a structure. What we're staring at, space-time, is just a bunch of number lines. Okay? And again, you have to distinguish between concepts and objects. He calls it entity, but entity is a synonym of object. There's no difference in physics between entity and object and physical. So he's saying the same thing, but he says an object is that which has shape, but physical entity is something measurable. Whatever that means. I mean, what do you mean measurable? So it's not an entity until you measure it. Do we have to wait until the measurer, the person who's going to be doing the measuring, right, comes over and measures? It's not an entity until you measure it. And so this is the issue. The issue is these people have no idea what they're even talking about. They don't know what even's coming out of their minds, their mouths, their pens. They just say words. For them, it's all meaningless anyway. Those are words. We do equations. And yeah, so to them, it doesn't matter what they say. It's just words, just noise. That's all it is. Okay, and then he goes on to the big word of mathematical physics today, which is the word field. They can't live without field. You remove field, all of mathematical physics dies. Why? Because quantum has moved from quantum to field theory. Quantum field theory, so they deal with fields today. Why? Because they want to unite it with general relativity, which is a field theory, field equations, right? So it's field with field, and if you remove the field, if you kill the field, all of mathematical physics dies. So the big word today is field. So I do attack the word field. It's a concept, but they want to turn it into an object. Really an object concept. They want the word field to be both a concept and an object. So they try to cover all the bases. That's the issue, okay? And so here it is. He says, is field a physical entity with values? Okay, so is it the entity or is it the values? Is it a physical object or is it a bunch of numbers? Which is the field? And so when you look it up, he added a physical entity. Nowhere will you find that definition. He put it in there by force because he wanted it, he needed it. And no, we can erase completely a physical entity. First of all, it's not a physical entity. It's just values at each point in space. But if he defines it as a physical entity, it cannot be values also. It's either one or the other. So either it's a physical entity and he's got to draw it, he's got to make a picture of it, not tell us that it is a physical entity because he just wants to force his religion on us. He's got to draw it. Okay, so the clown's got to draw it. Okay, and otherwise it remains what it is today. It's values. That's it. Values at each point in space. And he says fields aren't just numbers. So what do you mean just? Are you saying that they're both? That they're both entity, things, and also numbers, concepts? So he wants his field to be both because he's going to use them in two ways. He's going to say, look, it's a physical entity that's over here, but it's got values at each point in space. Well, it's one or the other. You can't have it both. It can't have these two meanings inside it. Okay, so yeah, he's got a contradiction in his definition. And again, the official version has nothing to do with physical entity. It's only values at each point in space. It's just numbers. He doesn't like that because it destroys his religion. He realizes that. Okay, I guess he's a clown, but sometimes I guess he comes into the real world and realizes that there's something wrong with his religion, right? And then he says it carries energy and momentum. How do you carry energy and momentum? Supports waves. I guess over its head, with its hands. It's measurable and mediates interaction. Yeah, again, you don't mediate interactions if it's not a physical object. Only physical objects can mediate. Mediators are physical. They're not numbers. Okay, they're not relations themselves. Okay, you have to have a physical object. And usually if it's between two objects, it better be an elongated physical object. Like a string, a rope, a chain, a cord of some kind. Coaxial. Well, you'll figure some more out. Anyway, it's got to be an elongated mediator. Then it's a physical object. Then it's a mediator. Otherwise, you're talking about numbers. You can't say the numbers bring two things together or push them apart. Okay, so he says numerical values represent physical quantities, whatever that means. What do you mean in physical quantity? There's no such thing as physical quantity. There's only quantities. Okay, either it's numbers or it's physical. Either it's a tree or it's a bunch of numbers. But see, they like to use the word physical. They just insert it in there. They don't even know what they're saying. They just say it's physical, whatever that is, And then he says fields have energy density, whatever that is. Energy density. Energy is a concept. So, concepts do not have density. Intelligence doesn't have density. Love doesn't have density, okay? You can't just use the word density and apply it to concepts. They carry momentum again. They propagate. How do you propagate a concept? What's propagating? What's the physical entity that's propagating? I mean, in order to propagate or in order to move, it had better be an object. Only an object can move. You cannot say a concept moves. Okay, love does not move. A heart might move, A brain might move, but not intelligence. Intelligence doesn't move because the brain moves. Okay, but this is the way these people talk. That's the language they develop. And says field mediation is an action at a distance. Oh, it's not? Well, if you got a bunch of numbers, what's the physical mediator that is, connecting the two things that are, affecting each other, that are interacting with each other? And so he says sources affect fields locally. Yeah, okay, locally, meaning it affects the numbers locally, something you can measure, right? Changes propagate at finite speed. Okay, so great. How do they propagate? By what medium? What mediate? What physical medium? Is it through a tree that's lying down, that's between the two objects? What's between the two objects? That's the question. Are we talking about, again, a coaxial wire, a chain? What are we talking about here? Targets respond to their local field. So he hasn't explained what connects one object to the other. He just uses this word field anytime he needs to put like a joker in a rummy game. He just needs to put it in there. And then he says fully causal. Well, yeah, I mean, you haven't explained the cause at all. I mean, so again, these people, try to get away with murder saying, I'm going to affect that thing over there and I'm going to do it with a field. What do you mean you're going to do it with a field? What does that mean? Field is a bunch of numbers. That's all it is. It's not a physical entity. It's not physical at all. It's just a bunch of numbers. And so what they say is we measure here, okay, you measure here, and then we measure between the two objects, okay, you measure between the objects, you have a bunch of numbers, right? And then the other one gets affected and we measure that one also. Okay, so we measured here, measured in the between, and measured at the end. Great. What physical object made this one affect that one or interacted with that one? You have to put an object. Like, if a fish moves somehow and the waves affect another fish, we understand that. We say, look, there was an ocean, there was water, a physical object called water, made of atoms, made of molecules, right? And this fish waved, the waves moved over to the other fish and it affected the other fish. We all understand that. We can illustrate it. We can put it on the board. We can make a film of it, right? We can see how, a whale splashes and another fish gets bumped because, the whale, shook the waves and it moved this little fish out of the way. We can all understand that. Now do that with two particles and a field, bunch of numbers. Remove the ocean. Now we're going to put a bunch of numbers in there, right? We're going to put the number 5, the number 6, the number 3, the number 9. You like those numbers? You want other numbers? Put any numbers you want. So we're saying this fish now, the whale, right? Let's talk about a whale. Whale shakes itself, big animal, mammal, right? Underwater, shakes the waters. Shakes the field. The bunch of numbers. All these numbers vibrate. They vibrate and they affect a little fish over there. Tell me, how this whale affected the fish. And that's what they can't do because they don't deal with whales, fishes, or oceans. They deal with, numbers, particles, which are really numbers. They don't have a physical object there. Then they have the mediator, which is not an ocean. It's a bunch of numbers. And then the ending point, the little fish, is also a bunch of numbers, just fewer numbers. The other guy's big numbers. This is little numbers, right? So we have big numbers through some mediator, some ocean of numbers affecting another bunch of numbers. Great. What have we learned about the physical interpretation, how a whale affected the little fish? We'll never figure it out with the mathematicians. Okay, then he goes into space-time. Great space-time. They love the space-time and space-time both, space, time, and space-time, right? So he defines space. What spatial measurements measure? So there's nothing before you measure. What is space before you measure? And then he gives some examples there, right? Then he goes time. What clocks measure? Well, the clocks don't measure. It's idiots known as mathematicians who do the measurements with their clocks. So you ask them, what did your clock measure? And the guy says, well, measured time. And so what is time? Well, I don't know. The clock, and I don't speak to the clock or to my wife anymore, so they don't tell me what time is. And so the guy never tells you what time it is. He says it's what a clock measures. So what is time? And they never have an answer for you. And again, it goes orders, events, and duration. Duration being time. So to use the word duration to define time is irrational because it's just a synonym. And then he talks about frame dependent. I don't know what picture frames have to do in this thing, Gravity dependent, what gravity has to do with time, we have no idea. As verified by technology. Yeah, great. Anyways, then he defines space-time. And he says it's arena. In Spanish, arena means sand. Because that's what they used to have at the Colosseum, so the sand would suck up the blood of the guy who died. So arena means sand. And so he says the unified sand of events. Oh, great. So that's what space-time is, a bunch of grains of sand. Yes, events at each point in space-time, right? With a metric and a curvature, whatever that means. Yeah, you can't have curvature of number lines. And that's what they illustrate there. Warped number lines, they say, oh, look, we can explain gravity. And one of those number lines is called time. So they're bending time. They're bending the seconds, the minutes, the hours, and years. I mean, it's all absolute nonsense, poppycock. None of that survives. It has nothing to do with rationality. It's got nothing to do with physics or science. It's got nothing to do with anything, not even with philosophy. It's just garbage, poppycock. Okay, here's another set of words that he tried to define. And here we have them. One is distance. And he says measurable spatial separation. Why did he use all that wordage? I mean, he thinks the more words he put in there, he's more intelligent. No, it just shows that he's an ignoramus. Why did he put the word measurable? I mean, is there distance before you measure anything? I mean, if you have two objects, one is separated from another. And you say, well, what's that space in between these two objects? Well, we call that distance. So far, you haven't measured anything. You just need to define what word you're going to use to define that space between these two objects, which is just separation, gap. That's all it is. And so these people say, oh, measurable. Well, if you don't measure, there's no distance. And what separation is there that is not measurable? Give me an example of a separation that is not measurable, okay? Because he says these are the measurable separations. So again, it shows this person never defined words in his life. He's giving it his first attempt, amateur, actually quite lousy. Unless he's a clown and he's trying to be funny, he is really being funny here. Existence. This is a big word in physics, because physics is the science of existence. So we are interested in the word exist, just like we are in the word object. Those two words are gold. They're holy words of physics. Okay, and it says an entity exists if it has what? Measurable properties. Okay, so how about the table that the Klingon has on the other side of the universe? Does that exist right now at this moment? I mean, can you measure it? And he might say what a lot of these clowns say, and they say, what's measurable? Well, how do you know it's measurable? I mean, how do you know it's measurable? I mean, do we have to travel to the land of the Klingons and pull out our measuring tape, or if you're going to measure its weight, a scale? I mean, what are we talking about here? How do you know you can measure if that's something that's going to happen in the future? You don't know if the table is measurable, okay? Whatever that means. You're saying you can measure it. Well, maybe his table is zero-dimensional for all we know. Maybe you went with your measuring tape, you can't measure it. Or maybe it doesn't weigh anything, like it's made out of photons, right? So it doesn't weigh anything. So how do you know it's measurable, right? I can play devil's advocate here and come up with all kinds of scenarios. And so we don't know if it's measurable. And the question is a table, the word table, does it represent a physical object anywhere in the universe at any point in time before we measure anything? Does it exist? Well, if the Klingon is sitting on a chair, right, does that chair exist? I haven't been able to measure it. I haven't gone over there, and I don't even need to go all the way to the Klingons' land. Just take a Chinese on the other side of the planet. He's sitting on a chair. Does that chair exist? And so the issue is, do we need to measure anything in order to verify that it exists? Does it mean that it doesn't exist until you go and measure it? The Chinaman sitting on what? In the air until you go and measure and say, yeah, verified and confirm that it's a chair. Measurement has nothing to do with it. And again, he wants to introduce the word measure and observation everywhere he can because that's his religion. You kill the word measure, the word observable, and he's dead. He's dead in the water. And then he defines motion. How does he define motion? As change. And I don't know what he put after that, irrelevant. Anyways, he died already on that word, the word change. What is change? To make something different than what it was. Meaning we already have motion. So no, motion is not change and change is not motion. You can't use the word change to define motion. Only irrational people define motion using the word change. What's a concept? Oh, I like this one. Mental linguistic representation used to categorize and reason about objects and blah, 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 blah. Yeah, and he mentions properties, relationships, processes, and abstractions, all of which are synonyms of concepts. So he says a concept is a representation of a concept. That's all he said. Yeah, and again, it shows, he's never defined words in his life. He's giving it his first shot, and he did a lousy job of all of it. He doesn't realize that no one in the last 10,000 years defined these words. And you need them to do physics. You need to have these words properly defined, very strictly defined, very rigorously defined, if you're going to give a physical interpretation, right? And this person says, I'm going to wing it. And he thinks on the first night he's going to get them all, He says, that's just easy, piece of cake. And it turns out no one has been able to define them in the last 10,000 years, especially this word we're going to be dealing with today, the word time. No one has any idea what time is today, and obviously this fellow doesn't either, right? Okay, and but this guy didn't come up with all this measuring, exist meaning measurement. This came out of this bozo. His name is Niels Bohr, and he says everything we call real is made of things that cannot be regarded as real. So the real is not made of real. This is the great, conclusion to which Niels Bohr arrived. And then he says, nothing exists, what? Until it is measured. So again, this bozo, Niels Bohr, he threw every generation after him, out of whack. He says you need to measure, then it exists. Because that's what he did. He used to do measurement. He goes to the lab. He says, I'm going to measure something. It's charge, it's, voltage, it's weight, whatever he measured. It doesn't matter. And he says, then if I can't measure it, it doesn't exist. So you can't measure the chair that the Klingon is sitting on. You can't measure the chair the Chinaman is sitting on the other side of the planet. And so his chair doesn't exist. He's sitting in the air until you go and measure. So again, it's all this irrationality that comes out of mathematics, mathematical physics. And yeah, none of their definitions, can walk a picometer, okay, without being destroyed completely. Okay, so here we have it. It continues. Mass inertial resistance. What's inertial? A property of matter. In fact, mass and inertia are considered synonyms. And there's 7 definitions in the Wikipedia for mass. So no, we don't have a definition for mass. He's trying to wing it again. Energy. What is that? Property of systems. Yeah, it's a property, but he forgets about that because he's going to reify that and turn it into a physical object. He's going to talk about carrying energy. How do you carry energy? He's going to talk about transfer energy. What do you mean? What is this nonsense? And then force, rate of change of momentum. Okay, so what's momentum? Force of movement. Okay, so and a couple other definitions. A quantity expressing the motion of a body. Okay, and again, so it's a quantity. Okay, and the product of mass times velocity. Again, quantities. But how about push? I mean, if I say, how did you move the box? And you would say, well, I used force. Oh, what force did you use? I pushed it. Oh, okay, so we all understand. And there you see a picture at the bottom of fellow, pushing. I mean, do you need to know how much momentum is, what the velocity is, what the mass is, to say that I pushed the box? That's how the box moved from A to B. That's what we're trying to explain. And so this guy said, oh, I need to know the momentum, otherwise I don't know how it moved from A to B. Well, you moved from A to B when you pushed it. This is baby stuff. This is kindergarten stuff. You just put your hands against the box, you push it and say, that's how it went from A to B. That's what you're trying to explain. You're trying to explain how the box moved from A to B. I don't need any momentum, any velocity, any acceleration. I don't need any mass. I don't need any of that nonsense. I don't need math at all to explain, right? How, why the box went from A to B, why it ended up at B. Okay, the why, the cause, the mechanism. Okay, so here we go with explanation. He says he starts by defining what he says is physical law, whatever that is, and they like to put the word physical everywhere. Okay, because by putting the word physical, they give you the misleading notion that they're talking about physics. That's why you always put the word physical, but they never define physical. Physical means object. That's what physical means. Okay, so this is a law of objects, you could say. And the first thing he says, a mathematical relationship. No, it's not a mathematical relationship of anything. Then he says that is broadly validated. Validated? That sounds like belief. It means that someone believes in this. Did you validate God? I mean, does God exist? Did you validate? Who validated? Was it the Vatican? The Catholic Church? Who validated anything on this planet? Validation just means that someone believes in it. That's all it is. It's an opinion. It's a religion. And then, of course, once he puts physical law, he wants to use that to give a definition for explanation. And he says, can be causal. Yeah, tell me about it. Yeah, it can be causal. But then he says law-based, meaning what he just talked about, the law of physics, right? The mathematical relationship. So that's what he wants to put in there. He says it's law-based. An explanation is law-based. A mathematical relationship is just a description. It's not an explanation. Never. And says sometimes it's mechanistic. Sometimes, we don't care about mechanistic, but sometimes, in philosophy and metaphysics, ontology, word salad, whatever, then it's mechanistic. Otherwise, we just do equations. And we base it on law. And what's law? The physical law. So they have all these contradictions, these self-contradictions. They're oxymorons, all of these. Fields and geometry legitimately explain. Absolutely not. Fields do not explain anything, neither does geometry. Geometry is simply a descriptive thing, discipline, It's got nothing to do with science. Geometry is simply math. Okay, remember how geometry came to be. It came to be because they tried to measure the land. And it started because, they had to have these surveyors measure the land to know whose land, this land is my land, that land is your land. And so they wanted to make sure that there wasn't fighting over the land, that neighbors could get along because they brought in a surveyor, put the stakes there and measured the land. So it was a description. You didn't explain anything with geometry. Geometry is simply a description. And, and again, field is also, it's just a description. All of math is descriptive. It has nothing to do with explanation. Okay, so here I say the following. Last week I talked about the gopher. I said, don't be a gopher. Okay, and what's a gopher? A gopher is a technician or an operator who uses his hands. Goes out there and goes for pizza, goes for coffee, goes to the machine, runs it, that's a gopher. Okay, so a gopher is not a scientist. The scientist is the guy who's upstairs using his brain. Okay, but he uses his brain. The fact that he uses his brain doesn't make him a scientist. He becomes a scientist when he explains to someone. Okay? So, I like to put that up there one more time. First of all, a scientist is not a gopher, is not the guy who works with his hands. Okay? No scientist ever worked with his hands. If you work with your hand, you're a gopher. You're not a scientist. So here we have, the difference between a gopher, which is the detective, the guy who goes out there and does all this investigation. He can even do thinking. No problem with doing thinking, right? But that's not the scientist. The scientist is the guy who comes to the court, right? And the court of jurors, human jurors, no, because it's not about belief. The only juror is Mother Nature, Father Universe, maybe God, the devil, one of those guys, right? You talk to nature out there. You talk to the universe. You talk to God. You talk to the devil. That's who you're giving your presentation to, right? You're trying to find out how this universe works, okay? So the scientist is the prosecutor, the guy who said, well, how does this universe work? I mean, how is it that the Earth doesn't fly out of the solar system? What does an atom look like? How come, a magnet attracts another? Those are the types of questions you're trying to answer, right? And so you're going to give a presentation. You're going to give an explanation to someone, but not a human being. A human being wants to sit around and listen to you. That's fine because they can hear you. And they say, hey, I learned something. There's a different explanation for how a magnet attracts another or how a pencil falls to the floor. No problem. But does that make it real? Does that make it the explanation? No, Mother Nature only knows that if that's true or not. We're never going to discover the real way that objects fall to the floor. All we can do is propose, brainstorm, propose theories, explain them, and that's the scientist. The scientist is the guy who comes up with ideas and explains them in a rational manner to you, or, well, really through you to Mother Nature, right? And so, the scientist is not the detective, not the gopher, not the guy who goes out there. But so he harps on the wrong thing. He says the following. He says, catastrophic gopher argument. Okay, Gaede's most self-defeating claim is that scientists should not perform experiments. No, I'm not saying they should not perform experiments. That's not the issue. The issue is you can perform all the experiments you want. In fact, you can drop the pen 5 million times if you want. When you come to the conference, you have to explain what caused the pencil to fall to the floor. So it's not that we prevent you from doing experiments. You can do all the experiments you want. That doesn't help you at all necessarily. Okay, maybe it does, maybe it doesn't. But when you come to the conference, we need for you to explain what caused it, what the mechanism was for the pencil to fall to the floor. And technicians or operators, the ones that use their hands, paleontologists who go out in the field and pull out bones, that's not a paleontologist. The paleontologist is the guy who stayed in his office thinking, and then he goes to the conference and says, I can explain to you how the dinosaurs disappeared. That's the guy who is the scientist, not the guy who cleans bones and puts them up in a museum and collects entrance fees. So he's a real scientists, he argues, are armchair physicists who only think. The scientist is the guy who explains. And I cite Hawking, he cites Hawking never looking through telescopes as validation. Hawking never did an experiment in his entire life. Neither did Roger Penrose, his sidekick. Okay, they never did experiments. What they did was they sat in their offices, and what did they do? They brainstormed ideas, and they popularized the black hole. Then Penrose got a Nobel Prize a couple years ago because he came up with some ideas, the naked singularity specifically, about black holes. That's it. And did he ever go to a black hole? Did he experiment a black hole? Did he observe a black hole? Absolutely not. He never did any experiment regarding black holes. They just sat in their offices and did what is called armchair physics. And they came up with irrational explanations, so they're not even physicists or scientists, neither one of these two individuals. Okay? That's why they get Nobel Prizes, because they just do mathematics. And so this fellow says, destroys his entire framework. If experimentation is irrelevant, then how do we choose? What makes rope theory superior? Gaede wants us to accept rope theory. Well, wrong, and wrong. First of all, choosing and what's superior has to do with religion. That has to do with your opinion. So we don't care how you choose. We don't care if it's superior or what's right or wrong, what's correct or incorrect. False, true. None of that has anything to do with science. All that has to do with religion, opinion. Okay? And no, I don't want you to accept rope theory. I want you to understand the rope hypothesis. Okay? So you need to understand, rope hypothesis, or what we call thread theory. Okay? Just understand it, then you walk away, you reach your own conclusions. We don't care whether you accept it or not, because again, acceptance has only to do with religion. Okay? It means you chose. It means you considered it superior. Okay? You can believe in anything you want. It doesn't mean that the world is going to follow you. Yet he provides no empirical criteria to prefer it over field theory. Again, preference has to do with religion. Okay? Nothing of this none of those words that he put in there has anything to do with science. And empirical, you can't empiricize anything. I mean, you drop a pen, why does it fall to the floor? You want to empiricize again? Just drop it 100 more times, And what does that tell you? Does that give you the mechanism of what caused it to fall? So empirical will not give you any answer to the invisible, intangible objects that Mother Nature and Father Universe use out there. Okay? That's what we have to identify. And the only way to identify them is through armchair physics. You sit in your office, you try to visualize, and only then can you try to figure out how Mother Nature and Father Universe run their shops. It says Gaede has preferences about explanation. No, it's not. It has nothing to do with preferences. We need to explain why a pencil falls to the ground, and for that you have to explain it. You have to visualize it. You have to make a movie of your mechanism or your the causes. Okay, the underlying causes. And that's why, mechanical visualizations. But why is it called quantum mechanics? What's the mechanics part of quantum? I mean, don't we need objects to do mechanics, any kind of mechanics? So he kind of laughs at me asking, for explanations. Explanations of physical phenomena, right, require objects. If I want to tell you how a motor works, I'm going to have to talk about objects, nuts and bolts and, this machine that's there, right? Imagine if I did it all in the abstract. I said, well, the energy and the force and the mass. The guy said, what are you talking about? I want to see a machine in front of me. I want to see the mechanism. And I want to see it rolling. And so, why is it called quantum mechanics? I mean, what's the mechanics part if you're not going to use objects? What kind of mechanics is that? So again, they laugh at classical mechanics. They say, well, we don't do that anymore. Yeah, but they're doing quantum mechanics, which is a more retarded, more irrational religion. That's what That's all they did. They went from more or less rational, which was not very rational because, again, they used a lot of concepts that they moved around. But when they went into quantum so-called mechanics, right, they lost it completely. They just invented an irrational language. They took the word field and, made a mess of things completely with that because they turned it into a physical object, and now the field is everything in quantum and in relativity, both. And also in string theory. Okay, so here talking about field. Okay, here we have visualization double standard, he says. Okay, why is it a double standard? bgaede demands visualizable mechanisms and offers ropes. Well, yeah, there's a rope. You can visualize it. You can see what I'm talking about. What's wrong with that? But ropes are equally abstract. Well, no, abstraction, a word that embodies or invokes two objects. You need to define the word abstract before you use it, if you're going to use it to criticize something. And of course, he says invisible and intangible. Well, that's not the definition of abstract. You have invisible and intangible objects. They're not abstract objects. What they are is invisible and intangible objects. That's what they're called. Abstract is the same word as concept. And the definition of a concept or abstraction, a word that embodies or invokes two objects. You have a better definition, put it up there. Let's see what abstraction is, right? What do you mean by abstraction? What is a concept? Again, you need to define these words. Ropes are abstractions, he says. No, they're not. Ropes are physical objects. I don't know where he got that they're abstractions. Here, let's show you that. Here's a rope. My good old rope. Is that a concept? Is that an abstraction? Or it looks like a physical object to me. Here, let me put it closer to you. Okay. Rope is a physical object. Always. Table is always a physical object. You can't say it's an abstraction. No. Even the table I'm dreaming of, I'm thinking of, the chair I'm thinking of, it's an object. It's an object you can't see or touch, but it's an object. The table I have in my mind, it's an object. The word table is always an object. The word chair is always an object. Okay? The word tree, the word rock, house, always objects. Okay? Even the one I'm dreaming of, even the one that is on the other side of the universe where the Klingon lives, that's also an object. The word table is always an object. The word rope is always an object. Okay, very simple. Okay, so here it is again. He condemns physicists for visualization tools while using identical tools himself. No, he thinks that a field is like a rope. It's not. Both invisible and intangible. Yeah, but invisible and tangible is not an object. That's not the definition of an object. An object is that which has shape, or as he said, what was it? That it's got a boundary? Yeah, it's that which has shape. That's what, and fields don't have shape because, among other things, they're, infinite. Fields are infinite. Numbers are, in three-dimensional, radially, they extend forever. Numbers go to the other side of heaven, okay? Both carry energy and momentum. Well, the ropes don't carry energy or momentum, believe me. They don't carry concepts, okay? And it says both mediate interactions. Well, mathematics reifies concepts, so they don't mediate anything. Fields do not mediate because it's a concept, it's a bunch of numbers, and there you see it on the right over there. That's what it is. A field is just a bunch of numbers. And so, numbers cannot physically mediate between two objects. They cannot have one object interact with another through a bunch of numbers. Okay, so again, the word field is fatal to the religion of mathematics. Okay, so he continues here and he says, it's important to go through all these words because, this is how the mathematicians define these things, okay? Here's a black hole. This is Felix, okay? And I showed this the other day, a couple of weeks ago, and what we see is, here's Felix. He throws a horseshoe right through a window, okay? Very simple thing. And so the judge asks the people who come to court, here's the owner of the shop, says, they broke my window. Okay, so how did it break the window? Well, Felix threw a horseshoe through it. Obviously, or he can say it was a metal horseshoe, but he threw a horseshoe through it. We all know what a horseshoe is, right? So maybe we don't need to explain any further. Okay, so now we know how the window broke. That's the question the judge asked. We want to know how the glass broke. Why all the glass is on the floor and there's a a horseshoe on top of the glass, okay? Simple, straightforward, kindergarten stuff, hopefully, right? And so here's the horseshoe flying, okay? We caught that glimpse there. Someone was filming it while little Felix threw it, okay? So there you see, just before that horseshoe hits the window, okay? I hope that's clear, okay? And then we see the glass on the floor, right? And we see all the, let me get this one out of here. We see all the horseshoe on top of the glass. There's some glass on top of the horseshoe. Great. So now we have it, right? How did the window break? Because a horseshoe went through the window. That's how the window broke. Any child can explain this, okay? Except a mathematician. How does a mathematician do it? Okay, here goes. This is the mathematical way, okay? It says the horseshoe fallacy, bgaede's horseshoe example supposedly proves physics doesn't need math, only objects. Exactly. We just need to explain how the window broke, okay? He argues a horseshoe went through the window is complete explanation. For what? For the mechanism that caused the window to break. Okay, let's get the proper things here. Okay, that's what we're trying to answer. We're trying to find out how the window broke. We want to likewise or similarly, right? Here, let's put it here. We want to explain why, right? Why the pencil fell downward. Why didn't it fall upwards, right? So we want to understand gravity and we say, why did the pencil fall downwards? I don't need to know anything other than what came in physical contact with the pencil, with every atom in the pencil, hopefully, right? Because mass times mass divided by distance squared, we have that completely in our brains, right, for 400 years. So we understand that, that's the description, mass divided by distance squared. That's what they use to send rockets into space. Okay, so it's very straightforward. Okay, so the question is, we're trying to find out why this pencil, falls downward. That's the question. Please focus on the question. I'll go beyond the question. I don't need to know the velocity. I don't need to know the acceleration. I don't need to know the mass of the pencil. I don't need to know the mass of the Earth or of the moon or of you. All I need to understand is the cause. What caused this to fall downward? And here we are, 10,000 years later, no one in mathematical physics can give you an answer to that simple baby kindergarten question. All we had to do was identify the invisible, intangible objects that are in contact with the pen, meaning every atom on Earth is connected to every atom on the pencil. Why? Because mass, distance squared. So it had better be like that, because that's what the equation tells you. Okay, if you're going to use equation. Okay, so he says the following. He says, this deeply confused. The question matters. Question 1. What broke the window? Answer, a horseshoe. Right, we're done. Finished. Fertig. Punkt, as the Germans would say. Question 2. Why did the horseshoe break the window instead of bouncing off? And he gives an answer to that. Something about tensile strength. And then he asks a third question. Says, how did the horseshoe transfer momentum to the glass? And he says the horseshoe went through, answers what, not how or why. No, we answered the why question. The why question is, why did the window break? What caused it to break? What was the mechanism? We answered that question. A horseshoe went through the window. That's the cause. That's a physical cause. That's what we were trying to answer. Just like we're trying to answer what caused the pencil to fall to the floor. And we say every atom on the pencil is connected to every atom on the Earth. We can all visualize that because there's a physical connector there. And so we say, okay, we understand why, the pencil fell to the floor. That's the question. And this guy's asking questions that the judge is not asking. So the judge asks him, how did the window break? Well, we measured the tensile strength and we can't understand why the horseshoe didn't bounce and the window broke. It's already broken. It's a consummated event. Okay, so it's not like if the horseshoe would have bounced, right? then the answer would have been the window didn't broke. You didn't have the question. You don't have a question to answer. There was no broken window to begin with. So we're trying to answer why the window broke. These guys are going off into left field trying to answer questions that are not to be even asked. I mean, like I said the other day, there's this guy, Charlie Kirk. He was shot, right? So these guys are saying, well, the mass, and what was the mass of the that flew? Because they don't even talk about object. They don't talk about bullets. They say, what was the energy? What was the force with which it hit? What was the tensile strength of his skin? You know, we just want to know how the guy died, how he was killed. Just tell me, you know, why the guy died. The cause. The cause is a bullet went through his neck. That's the cause. That's how he died. That's the why. That's the mechanism. And this guy is saying, well, what was the tensile strength of, you know, his skin? I mean, what the hell? That's how irrational these people are. They're mentally retarded individuals. They've been brainwashed so much on measurement and observation and all this stuff. You know, what observation are you going to have for the invisible, intangible mediators that Mother Nature uses? Why doesn't the Earth fly out of the solar system? What observation are you going to do? Are you going to go out there and see if you can touch something that's holding the Earth to the sun? You know, you can only measure what the visible objects are, like the Earth, but you can't tell me what's keeping it bound to the sun. And if every atom of the Earth is bound to every atom of the sun, and the sun twirls the Earth around like this, now we can understand why the Earth doesn't fly out of the solar system. It doesn't fly out because every atom of the Earth is bound to every atom of the sun, and the sun just twirls it around like, you know, a bunch of Lilliputians would twirl Gulliver around at the end of ropes. So that's the answer. But you're not going to answer the question by saying, oh, mass and the force and the energy and the time, you know. That's not going to give you a physical interpretation, which is the question we're trying to answer. So again, all these people start asking questions that have nothing to do with the issue at hand, with the question that's being asked. The judge just wants to know how the window broke. Please answer the question. And so he's saying, oh, what's the tensile strength? Who cares? No, it's not the question. Okay, and here's talks about me misrepresenting quantum mechanics. Gaede lists quantum absurdities, absolutely, as proof of irrationality. Well, we don't prove it's just irrational. All of mathematical physics, but quantum particularly, I guess, is irrational. And so some of the examples: superposition, tunneling, wave-particle duality, spin, you know, particles at two places at once, particles coming from the future, tachyons and so on, virtual particles popping in from the void. All that's got nothing to do with science, with physics, it's got to do only with supernaturalness. Okay, just like angels and spirits, it's even worse, because an angel I can more or less imagine. I can imagine Casper the Friendly Ghost and say, well, that's an angel, that's a ghost. Okay, more or less I got it. You know, a bed sheet in the shape of a human. Okay, we got it. But, you know, the particle at two places at once. Not even Casper can do that. I mean, Casper can only be here or there, you know. God can only be here or there. But when God is at two places at once, it's because you overdid it on the booze. Okay? And so here it is. But these are among the most precisely verified. What does precisely or precise accuracy, right, and verified have anything to do with science or with physics? And he says they've been verified by mathematicians. Okay, great. And so there we have, he gives a couple examples. One of them is Tanimura, who ran his one electron at a time. And so the only way Tanimura could come up with that physical interpretation is if he used the ridiculous, the irrational quantum atom, okay, which is a little bead that is somewhere around the proton, and the question is, if the bead is negative and positive attracts negative and the nucleus is positive, why doesn't the bead fall all the way to the nucleus? Or why doesn't the bead fly away completely, you know, out of the atom spontaneously? And so first you got to talk about the atom before you can say this dribble that Tanamura talked about, handling one electron at a time. He doesn't even know what he did. Okay, so maybe that proved it to a mathematician, doesn't prove it to a rational individual. And then, well, he talks about tunneling and atomic orbitals. Again, a pure poppycock, because an orbital is not a physical object. It's just a concept. And then you have this spin. And the issue there is that they never define spin. They have no idea what spin is. It's a number, they say. And they say, by the way, it's specifically not like a top spinning. And the next thing they do is they always show it as a spinning top. They always illustrate it as a spinning top. So, yeah, we have a problem because these people have contradiction after contradiction after contradiction. And so you can't follow their physical interpretations. And then they say, well, that's ontology, that's metaphysics, word salad, we don't care about that. You took it too literally, or, that's not science because we can't verify it, or they come up with some stupid answer and they go back to doing math and equations. And so, we have our descriptions. Okay, so here's the last one, black hole. He touched upon the black hole. He says the black hole evasion. Oh, I evaded. I don't know what I evaded there. Gaede claims black holes are what? Two concepts. Singularity plus event horizon. That's absolutely true. I mean, that's a fact. That's how it's defined. It's defined as a singularity at the center surrounded by an event horizon. That's it. And singularity is a concept, so is the event horizon. Okay, so it's not real. Absolutely. Only objects can be real. An object that is real is an object that has location. Okay, so that's what an object is, what real means, what existence means. We have a definition that is consistent all across our lecture. It says, but general relativity's black hole predictions are verified. Verified? What is verified? Who verified this? I mean, was it the Pope? The Dalai Lama? Who verifies this nonsense? Okay? And so he uses all these words. He goes confirmation, observation, falsification, prediction. He's talking about authority, tradition, and democracy. All the mathematicians at the club, they voted for it, so they call it democracy. If 50% plus one, it becomes a fact. That's how they do it. And, what is a black hole? Well, there you see a black hole. It's got what? A singularity. What is a singularity? Well, it depends on what mathematician you talk to. Some of them think it's an object, a zero-dimensional object, whatever that is. And others think that it's a hole like in space, that all matter falls towards it, but never reaches it. So all the matter is still between the singularity and the event horizon. None of it has been crushed out of existence. And others say, well, all matter has been crushed out of existence, but it hasn't reached the singularity, whatever that is, because the laws of physics break down on the singularity, meaning we have infinities. And so because it has infinities, they see the laws break down there. And so we don't know what a singularity is. Obviously, it's a concept that involves infinities, and then it's surrounded by this nonsense, this poppycock known as event horizon, which is, again, I like to liken it to campfire. The campfire is like the singularity, and then you have this heat, and this heat extends to the edge of the forest somewhere, right? And at some point, the heat, you can't feel the heat anymore, or the temperature is normal temperature of the day. So if you're in winter, right, for example, at some point you're cold. It's 0 degrees. But the closer you get to the campfire, well, it gets warmer and warmer and warmer, right? Well, at some point we have the escape velocity of temperature, and at that point we call that the event horizon. That's as far as the heat reaches, okay? And that's what an event horizon is. It's a region of influence of the singularity, which is a concept. And we can throw all that in the trash can anyways, because the only question they have to answer is, even if we concede all of that, is how does mass, a concept, kilograms, right, affect a star far away? Okay, so if a star goes around, the visible star is going around nothing around a center, they say in that center there's got to be a black hole. Well, that's an assumption. if you can justify the black hole, which they can't because they don't have a definition for a black hole that is rational, right? It's not a physical object. So even if we concede that, why does a star go around the black hole? What is physically connecting the alleged black hole object, the thingy, right, which ain't a thingy? What is physically connecting that to the star, right? Because if the star's going around it, you have to tell me what is in contact with the star, what is touching the skin of the star, right? Or flaying it alive, because sometimes they say that the black hole sucks the gases, the surface skin of the stars. Okay, fine. How does it do it? By what mechanism? Explain the why. Don't tell me it does. Don't tell me you measure. Don't tell me it's mass, gravity, or whatever nonsense. Give me the physical mechanism. Show me what physical object is in contact with a star. So even if I concede your stupid black hole, you got to explain the mechanism. What is the connection between the black hole thingy, right, and the star? That's all you got to explain. See how easy it is? Baby stuff. Okay, so you can see all the definitions this fellow uses are, well, he's an amateur. He's a clown. That's what he is. So, no, none of his definitions are worth anything. And it explains a lot as far as, why in the last 10,000 years, not a single one of these individuals has ever been able to define any of the words needed to do physics, meaning explanations, physical interpretations, rational physical interpretations of phenomena. Okay, let's move on to the subject matter today, which is quite interesting today. Hopefully people can follow along. And it's got to do with this fellow Einstein. And I don't think he believed in the block universe, but I got to give it to him because everybody says, oh, because of Einstein. Okay, so let's give it to Einstein. Let's bring Einstein down. We need to destroy the name Einstein no matter what. Not because we have something against Einstein, because he didn't believe in black holes. He did not believe in Big Bang. He did not believe in gravity waves. He wrote papers against each one of these, right? And but because everybody says, oh, because of Einstein, then we have to destroy Einstein's name. So if you ever see me bring my axe down on Einstein, it's because of that, because we have to destroy his name as a synonym of intelligence. He was not an intelligent individual. He was an ignoramus. He died an ignoramus. He could not explain how this universe works. So yes, in this site, we destroy the name of Einstein, okay? Also the name of Newton, also the name of Hawking, okay? So we want to make sure all those names are wiped out from the history books. They fall into the ash heap of history, okay? Maybe don't even belong there. They never discovered how this universe works. Okay, so here we have good old Einstein. I call him Einie. And this is a block universe, okay? And he's got this Big Bang. That's where it all started, a big explosion or some kind of expansion that took place. Okay, they never explain what happened at frame number 1. They always start at frame number 2. Okay, so this thing expands through time, as they say. And first thing you should notice is that this whole thingy that you see there, the question is what's on the outside of it? What's it pushing up against? What's it displacing? And they say, what's this? It's a wrong question. You can't ask that question. It's not pushing up against anything. Well, if it's not pushing up against anything, how is it that we have multiverses? How is it we have all these other universes out there, right? What separates one universe from another if each universe has space, time, and matter? So what's the entity? What's the thingy that stands between any two universes, two parallel universes, for example? And so that's one issue you should keep in mind. But here the issue is another one, and it's that as you go from the past to the future going into your eyes, kind of, right? Somewhere in between we have the present, okay? And those lines that you see, there's those white lines that are going around. Those are slices of time. That's what they're going to say, that those are slices of time. So, one of the tenets, you could say, especially of special relativity, is that you can go backward and forward in time. Primarily forward. There's a debate on whether you can go backward in time, but certainly you can go forward in time from one of those white lines to one of the white lines in the future. Okay, that's what they're saying. That you can just hop over if you had the right technology, right? And you would land sometime in the future and talk to your grandson or whatever, right? So this is what they say, right? This is the notions these people spread out there to the public. And people believe it on the basis of authority. They say, well, how can these people be wrong? They studied 10 years of mathematics at the university. They're the smartest people on earth. If they don't know, who does? So that's how they handle that. It's all authority. It's all push through propaganda, okay? Relativity propaganda. Okay, so, but what's the issue here? They talk about time, the universe expanding through time, whatever that means, like time is a medium of some kind. You're going through it like water, like air, or something like that. And so the universe is expanding through time, they say. But then it comes the knockout blow, the fatal blow to general relativity. All these people say, we don't know what time is. We have no idea what time is. What do you mean you don't? You've done all this special relativity, special, right? Especially. It's all based on time. And after they did their 2-hour dissertation, they say, oh, by the way, we have no idea what time is. So hold it, you have an equation, you measured, and you do all these fancy things with the numbers and with the variables, and at the end of the show you tell me, oh, by the way, we have no idea what time is. That's where you get the heart attack. And here you have one fellow, several fellows, in fact. These are all mathematicians, every one of these, and they're going to tell you that they have no clue what time is. Okay, let's make sure we establish that. Nobody in mathematics has any idea what time is. So let's listen to these folks. Here goes.
What do we really know about time? If time isn't what we all think it is, then what is it? Did it have a beginning? Will it have an end? Where did it come from?
Time is the thing that everyone knows intimately until you ask them to tell you about it. What is time is really the $64,000 question to physics. There's basically no aspect of time which we really fully understand.
By only having definitions that harken back to the notion of time itself.
So, did you learn what time is from these experts? 10 years at the university, and not one of them was able to define the word time. They don't know what time is. And obviously, we've had last few thousand years. I mean, Aristotle, he talked about time. He tried to define time. In fact, he thought he did a good job, which he didn't. And here's good old Ari, and what does he say? He says, time is present equally everywhere and with all things. It's equally present everywhere? I mean, what do you mean it's present? Like a chair is present? It exists? Time is continuous, divisible, because continuous to Ari is the opposite of continuous. Continuous means that it's smooth and there's no breaks. And he says it's divisible. Well, if it's divisible, it's not made out of a single piece. So, in physical terms, that's what divisible means, okay? And so he's talking about math. He's saying that it's just a bunch of numbers you can divide, between any two numbers, you'll find a whole bunch of other numbers. That's what he was saying. Time is neither fast nor slow, but many or few, long or short. Okay, so it's not fast or slow, okay? Time doesn't move fast or too slow, okay? Time does not exist without change or movement. Well, time does not exist, period, okay? There's no such thing as time. Time is not a physical object. Only physical objects can be said to exist in physics, okay? In ordinary speech, you can say whatever you want. But he said time is a measure of motion. And before they said without change or movement, which is more or less the same thing. He said time is a measure of motion. The way he finally ended up defining, he says time is quantity of motion, amount of motion. Okay, you put a number for the amount of motion. It's motion in numerical form, so to speak. Okay, so that's how he ended up with the definition of time. Okay, and well, nobody uses his definition today. But again, they have no definition of time, so it doesn't matter whether Aristotle said it or whoever. No one has a definition of time. In fact, Newton said, I don't define in his scholium, right? Principia, right? He said, I don't define time because, well, we all know what it means, what it is. Oh, okay, we all know what it is. Why define it, right? Why take the trouble? So yeah, Newton did not define it. Nobody since then has defined it. Einstein said it's what a clock measures and so on. In fact, here's the NIST, National Institute of Standards, right? And I mean, if they don't know what time is, they measure time. They're the timekeepers, right? For the U.S. at least, right? And so what do they say? Well, first of all, when you go to their site, see, you find this notice, due to a lapse in annual appropriations, most of this website is not being updated. Yeah, I think they should fire all of them. Same in NASA. Oh, fire all those people. They're wasting money. All these relativists that work there, we don't need them. What are they doing? You know, I mean, again, this is a waste of money. So I have no problem with all these people being wiped out. They should be defunded completely. So what is their definition of time? I mean, if the NIST doesn't know, who does, right? Time appears to be the most bizarre of our basic units. Bad way to start a presentation. St. Augustine remarked, what then is time? If no one asks me, I know what it is. If I wish to explain it to him who asks, I do not know. Which is what everybody essentially says. I mean, we haven't advanced anything since the days of St. Augustine. Philosophically, time is a slippery creature. Again, he's telling me, look, I don't want you to get your hopes up, but I think you're getting the message. I don't think I have a definition for time. That's what they're telling you, right? And in fact, that's exactly how it ends. It says, even Einstein concluded that after much thought, time is what a clock measures. Oh, great. What does a clock measure? Clocks don't measure. It's stupid idiot mathematicians who do measurements with clocks. They're supposed to tell us what the clock measures. And so what did the clock measure? It measured time. So what is time? Well, I don't know. The clock and my wife are not speaking to me today, and so I don't know. Okay, so we'll wait till they speak to you once more time. And my wife divorced me and the clock stopped, and so I don't know what time is. Whatever time is, we can measure the passage of time. Yeah, they measure, but these morons, these idiots, they don't know what they're measuring. First, you have to define time so you know what you're measuring. And there we have the explanation or the definition of time right there at the bottom. You see it. It's a comparison of two motions. That's what time has always been. That's what we're pondering. That's what time is. That's what we have in front of us. What are we doing? We're measuring, for example, this is just an example. We're measuring the orbit of the Earth around the sun. When it goes 30 kilometers, the second hand on your watch goes one tick mark. So one tick mark, 1 second is equal to 30 kilometers of the Earth around the sun. We're measuring the motion of one object against the motion of another object. That's time we're done with. Not quite. In order to understand that, you have to have memory. You have to memorize the previous locations. Okay? You can't do time without memory. Time demands memory. Okay? So memory, comparison of two motions, we're done. Now we are done. Completely done. We don't need anything more to understand time. We have no use for time in physics because physics is about explaining. Time does not explain anything. Time can only describe, and they measure, they do calculations. Again, just a bunch of descriptions that have nothing to do with explanations, meaning physics and science. Okay, here's the Wikipedia definition of time, so hold on to your hats here. Here we have it. Time, the continuous progression of existence that occurs in succession from the past to the present and into the future. What is the past? the set of all events that occurred before a given point in time. What is the present? The period of time that is occurring right now. Again, when they use time to define past, present, then they use past, present to define time. What is the future? The time after the past and the present. Loved it. Absolutely love it. So those are your definition. Now you know what time is. Exactly. Okay. And then in another site of Wikipedia, it says, in mathematics, I think it said mathematics, time is defined by its measurement. What is time? What a clock measures or reads, which is what Einstein said. In other words, they have no idea what time is. Okay, it's whatever the clock measures. We don't know what a clock measures, so a clock is not speaking to us. It doesn't want to talk to us anymore. Okay, so we don't know what time is. We have an excuse at least. Okay, so you go to the AI. Maybe the AI is smarter. You know, the R2D2. And the AI tells us what? It says, doesn't tell us, it doesn't give us a definition, but it says that it absolutely asserts without any explanation, right? That you can go to the future and, you know, traveling to the future is possible. And maybe even to the past, but that's debatable. So they don't define time, but they tell you that you can travel through time, in time, across time, in the direction of time, whatever direction that is. I don't know if it's that direction, that direction. I wish I knew, because I want to go backward in time, become 20 years old again. But I never found a direction in that direction, you know, time. Terrible. Okay, so here we have good old Brian Greene, and he's going to reach the conclusion that even though, you know, the clocks can measure time, they cannot tell you what time is. So the fact that these people say, well, it's whatever a clock measures, it doesn't tell us anything. Listen to him.
No matter how accurate our clocks have become, time remains a mystery. Clocks can tell us what time it is, but they haven't been able to tell us what is it we're actually measuring.
Okay, so it's straightforward. They have no idea what time is. But then they created this notion in mathematics that time is some kind of a field. You know, they love the word field. And time is a field, you know, because you have different points, different clocks, different measurements of time, depending on where your clock is out there. They have different measurements. So you have this field of time, okay? And try to illustrate it. It looks something like this, okay? That's the relativity's field of time, okay? All these clocks measuring different things at different locations in space, right? Okay, so we have a notion of time, but then Brian Greene, he really scares me, because he says, you know, you have this field, but this field is not static. Remember, the field is vibrating, it's moving, it's changing at every location in space, okay? So the field is not static. It's just, there are values, but these values are changing from moment to moment. Time is changing from moment to moment. And he says, even if you stand still, rigid, you know, like a tree, like that, you're not moving through space, but you're moving through time. Because all this field of time, I guess, is flowing right through you. You can't stop it. You're standing still, but the field is going right through you, I guess. So this field concept of time is really what these people are talking about. Listen to him. Okay, here it goes.
I may not be moving through space, but I am moving through time. I mean, after all, my watch just keeps on ticking and ticking. And as long as I'm standing still, that is, not moving through space, Einstein said that all of my motion is through time. Some of my previous motion through time is being diverted into my motion through space.
Scary stuff. You stand still, but you're moving through time. Not through space. You're not moving from here to there. You're moving through time even though you're standing still. Jesus, all this field going through you, I hope it doesn't affect my heart, But then he does something even worse, this Brian Greene. He says something completely outrageous. He says that, you have all these slices of time that we talked about with Einstein's, this space-time universe, this Big Bang expanding through time or whatever, right? And he says the following. He says, you have all these slices of time. So listen to him. He's going to talk about these slices of time, those lines that you saw, right? All those are slices of time. And he's going to build this loaf of bread. He says it's like a loaf of bread. He's going to build this block universe with that, right? With all these slices of time, these cross sections of time, right? Listen to him.
Think of space-time as a loaf of bread. There are different ways to cut space-time into individual now slices.
Our past may not be gone. Our future may already exist. Think of all moments of time as already existing.
Once we know that your now can be what I consider the past, or your now can be what I consider the future, and your now is every bit as valid as my now, then we learn that the past must be real. The future must be real. They could be your now. That means past, present, future, all equally real. They all exist.
Just as we think of all of space as being out there, we should think of all of time as being out there too. Everything that has ever happened or will happen, it all exists.
Okay, so I hope you got the concept that they wanted to get across. If you cut the loaf, Big Bang expanding through time, right? We can slice the universe or the expansion, right? Through time, we can have all these time slices, okay? And what comes next after that is this notion in relativity that you can go into the past or into the future, right? Because if you travel fast enough, you go to a black hole, or you jump through a wormhole like Brian Greene explains in other videos, you can go backward in time. Okay, when you come back, your twin brother age. Well, you're still young, so in a way, you either went to the future or went to the past. I don't know. He said if you jump into a wormhole, you can end up seeing yourself in the morning, so you're kind of going back in time. So they have all this nonsense, Hollywood nonsense, and this is what they feed as science to the public. That's where the problem is. See, if they kept it in their nut house out there in Oxford and Harvard, we wouldn't care. But they feed it to the public as reality, as something they measured as truth, as fact. That's where the problem is. All this irrationality is reaching the public when it should never have even be in the what they call the scientific literature, which ain't scientific at all. Okay, so here we have, because of that, he ended up with these cross sections of time, okay, these slices of time in the loaf of bread of space-time, right? This is irrational, totally irrational. There's a contradiction. It's fatal to the religion of special relativity, okay? Let me show you why. This is totally irrational, has no place in science, in rationality. And the way we do that is we bring the my tool that I created. It's known as the universal movie. So very briefly, what we have is in a single frame of the universal movie, all we have is every atom in the universe, every object that exists, okay? So in a single frame, every atom in the universe, in the next frame, every atom moves to a new location. That's all we have. So in a single frame, everything is there. Everything that exists. Every atom, every object that you can imagine is in there. Okay? So if God takes a snapshot of the universe from outside our universe, let's assume he can do that. A little surrealistic, but let's assume he can do that. In that picture, you should find every atom in the universe. That's what's in a single frame of that movie. Okay? So that's what we're illustrating here. Okay? And so what's the problem with what good old Brian Brain Green? He's got these cross sections, these slices of time. Something's wrong there. And let me tell you what's wrong. You need two frames you need two slices to conceptualize time. You can't do it in a single slice. There is no such thing as one slice of time, a cross-section of time, because a cross-section of time is called location. It's a static concept. Time is a dynamic concept. You need motion. Motion requires two frames of the universal movie. You need the particle, whatever particle, you need every atom in the universe to be at least at two locations, but it can only be at two locations if you have two frames of the movie. Okay, that's the argument. Okay, so here it is. Time requires two slices. Okay, you can't have one slice and have time in there. Okay, so this notion that you can have this, a movie in the present tense, right? That cannot be. You cannot have time in a single frame of the movie because you need at least two frames in order to conceptualize time. Okay, so this is where we're having a problem. Okay, this is the fatal problem of what these people are saying. Here's an illustration of that. Okay, what these people are saying, that in each frame of the movie you have time. So instead of having a static cross section, what they're saying is a single frame, you have motion, you have time already in there. This is the cross section of time. This is the slice of time that they're talking about. Whether it's past, present, or future, these require, each one of those, past, present, future, require at least two frames of the movie. They're saying that in a single frame you can conceptualize past, present, or future. And this is absolute nonsense. You cannot have a movie within a frame. What they're saying is that you've got motion within a picture. Okay, imagine you have a picture on the wall, right? I guess what was his name? Portrait of Dorian Gray, right? The picture of Dorian Gray, and you have the picture, and the picture gets older. That's more or less what these people are saying. That's okay in relativity, maybe not in science, okay? And so here you have it, what's before and after, at least the present, right, is blank. There's no atoms there because all the atoms have moved to the present, from the past to the present. So they better not be in the past still, and they better not be in the future yet, okay? They're in the present. They cannot be at two places at once unless you're creating clones of every atom in the universe in every frame. That means only then can you go back and land on atoms because the atoms are still there, right? But if every atom in the universe moves to a new location, it's no longer at a previous location, then the past has to be a blank. It's only in your mind. It's not out there in reality. The atoms don't exist anymore in those locations. They're no longer there. They're now over here where you are in the present. So the correct thing is to look at this like this. We got to scratch past, present, and future completely because these have to do with time, and what you have in front of you, you only have location. Cross-section, in other words, a single frame only has location, has static concepts. An atom can only be at one place, and so these people don't understand that they think they can get away with having motion within a picture, within a single frame of the universal movie. And again, what this means is that, the atoms are making clones of themselves instead of moving. Okay, so instead of the atom moving from A to B, it makes a clone at B, and it's also still at A, and at B, a C, a D. At every frame in the film, the atom is still there. It's just at a different location from where it is in the present. Only then can you go back and land on that atom, or see that atom in some way, come in contact with that atom. If that's only in memory, then if you go to the past, you're going to land on absolutely nothing. Okay, and that's what these people do with their thought experiments, right? That's how they get all this shit done. Okay, so this is what you would see. You have all the atoms in the universe at a single frame. Okay, and you don't have the previous location, that's blank, and you don't have it in the next frame, it's blank also. You only have them in the present. In the next frame, they all change locations. They do not duplicate, they do not make clones of themselves. And that is what these people are saying. They're saying that within a single frame, you have time, and they call that a slice of time. Absolutely not, because what they're saying is there's motion within a photograph. That ain't so. Okay, I'm going to open up the floor for questions. Anybody who wants to ask questions and lecture today or some other stuff, go ahead. Give me 10 seconds to receive the message, and I'll try to answer you in about as much time as that. Paul says, in the rope model, electricity is the spinning of whole atoms, or rather molecules, okay? I know, I say atoms just for, okay, no problem, for simplicity. And ionization is the spinning of only the shells. Okay, so electricity, the proton star spins too, but in ionization it does not. In ionization it does not. Well, again, it's something I have never addressed, but it's a good question for anyone who wants to tackle it. Does the proton spin? I think it does. Not so much necessarily because the proton is spinning, but we say that the electron shell is spinning around. In other words, it's spinning around the center of the atom. So yeah, you could say that if the if the shell, the electron shell, the membrane, which looks like this, right? Like like ball of yarn. Okay, so that's how you got to think of this. Gazillions of threads weaving the electron shell, and at the same time it's spinning, and the threads are moving, they're sliding, right? There's a whole lot of motion at the same time that the atom is pumping back and forth, doing its quantum jump. There's all this motion going on. If the whole electron membrane is spinning, then you would think that the proton is also spinning somewhere inside it with respect to the electron shell. Is it spinning with respect to other atoms? I think it does too. And again, people have a hard time visualizing all this, and it is not easy to visualize. Let me tell you why. Because we're thinking in macro terms. We're saying, well, if I put a star within a shell, within a balloon, right, and I move it, and that star is connected to another balloon with a star in it, how can I move this one around and not drag the rope? That's one issue. How can I not affect the other atom? And the answer is yes and no. We're talking about Mother Nature's universe. And what I'm saying is that the rope does not have the ability to touch. And that's very hard for people to grasp because we're thinking in macro terms all the time as far as touch and see is concerned. Those are the two main ones. The fact that we say, hey, I'm touching. Yeah, you're touching because you have atoms. Atoms have these shells, electron shells. There's a surface there, and it's what is it? What's the word I'm looking for? It's an emergent property. Mother Nature, in its rope itself, in the thread itself, does not have touch. The touch comes in when you have gazillions of threads. Now you create a surface. Now you have touch. And so people have trouble with touch and, understanding this touch thingy that Mother Nature does. And that's why it's so difficult to understand, what Mother Nature's doing out there, in the quantum or Father Universe, in the macro world, because we're saying, well, we can't see the mediators. Okay, so you put a rope now, you can explain gravity, you can explain light, but how does the atom do all these weird things? Well, again, forget about touch. You have to forget about touch when you have the atom going across the rope, okay? And the rope itself is not bothered essentially by the electron shell because it forks into the electron shell and into the proton, dandelion, or star. So, it's very hard because you're trying to visualize something that you're trying to put in macro terms. And again, you have to be extremely careful with that. You got to do a lot of thinking about that. Okay, visualization. Okay, Paul says, but the same electricity from ionization, or are they the same thing? Well, no, electricity and ionization are two different things. Ionization has threads, okay, moving around, okay? So if they both go in the same direction, right, you have the threads coming down from one atom and the threads coming up from another. There you have the attraction. That's the bond, right, the covalent bond. You have this not merging, really. What it is a static that you create because there is a very insignificant friction at Mother Nature's level, okay? I theorize that it's not completely no touch, okay? At Mother Nature's level, there is a tiny friction under certain circumstances, which has to do, again, with the speed at which these threads move around. That's one issue. And the other one is, how many of them? Do you need to have a surface, okay, a certain surface for there to be touch? Now, so you got to be very careful with this part of it because that's the one that tricks, that really confuses a lot of people out there. And what I'm saying is ionization is threads coming down, threads coming up. Now you have attraction, and that's why you have, the atoms binding to each other. Okay, not necessarily the hydrogen bond, which is a single rope. This is a hydrogen bond right there. Two atoms bound by a rope. Okay, somehow. That's a little different covalent bond where you have, one going through the other. But this is the issue. The issue is that that's ionization, or you have all these bonds, okay, in chemistry. Those we explain by threads moving around. When you're talking about when you're talking about electricity, you're talking about merged shells. Okay, so now you have all these merged shells. And they go around like I call a serpentine. They're all elongated merged shells, and they all turn around. They all turn around in situ. By doing so, they release threads that move around. Those are going to form the magnetic field. Okay, those lines of force, those are the threads moving around. And meanwhile, what you have is the rotation of all these molecules, and we'll call them atoms, again, for simplicity's sake, merged atoms, and they form the serpentine, and they spin around, and that's electricity. What is positive and negative? From this end, you have clockwise. From that end, it had better be counterclockwise. It had better be opposite of clockwise. Okay, so that's what you need to visualize. A lot of this is in the books in a lot more detail, okay, and also there's some videos out there on the subject. Okay, here we have, so another, what this is, okay. Because the electron shell is connected from all angles, would it mean that the spin is not unidirectional? That's what I would expect. Yeah, again, we have to try to ponder what's happening to the rope. The rope remains between two atoms, but remember, one of the things that Mother Nature allows is for this thing to, it's like you have molasses connected to molasses. So you have a string of molasses that you're dripping, right? And assuming, you have that drip and it blends into the pool of molasses. So even though this thingy, that's the thin one, that's connecting these two molasses, right? At the same time, they melt, they blend into the molasses. So Mother Nature has this thread that has these properties that we see in our macro world. What are they? Well, at the same time that it's a thread, like a physical thread, like a rope, right? At the same time, it has the property of melting into itself. Okay? So it's got all these properties that we see in our world. It has the gaseous phase, the liquid phase, and it has a solid phase. It has these three phases. The only three phases of matter, by the way. Plasma is not a phase, not a state. Forget about that, but that's a long story. Anyways, it's got all these properties, these attributes. It can melt like water melts into water, right? Or molasses into molasses. It's solid also, right? It's a solid, it's like a rope. And it has these gaseous phases as well. It has these properties. That's why we have these properties in our macro world, because they are part of the properties, the attributes of the thread itself, of the universal thread. So you have to try to figure out how to include these attributes in the rope or in the thread when you're trying to explain something. And that's not easy, because people get confused the macro with Mother Nature's world. And the properties of one do translate into another, but not in the same way. That's why we're all confused. That's why we've been confused for the last 100 years at least with quantum mechanics, because they say, well, it looks like a particle is at two places at once. No, it's that Mother Nature doesn't do magic of that nature. She does another kind of magic, and we have to understand it under the rope model. Okay, at least that's what we propose in this site. Do you believe in it? Hopefully you don't. Hopefully you understand it. Okay, with all atoms near each other in a conductor such as copper, would electricity not be the atoms all rotating along with their ropes like a drill, but not just the ropes, and instead the atoms too? Well, remember the ropes could come out of two places to form the magnetic field, okay? There's two possibilities. One possibility is they come from the ropes. Another one is they come from the atoms, the surface of the electron shell, which is made out of gazillions of threads. So, the atoms are spinning, so maybe the threads are coming out of the atoms. And some of them may even come from the ropes for all we know. This is something you have to hypothesize. You said, let us assume, and then you theorize, okay? You can use one or the other, or you can use both. I use both. I try to think that it comes out of ropes and it comes out of atoms as well. In other words, electron shells. And that's the field, the magnetic field. But how about the atoms? Well, the atoms don't get completely, they're not naked. We don't have naked singularities in the rope model. There's no such thing as just a proton star that has no skin, no electron shell around it. Okay, when they say they accelerate protons, well, you got to look at that. What are they really doing? Are they sending atoms through the beamline? Are they spinning them? And it's a whole row, long row, right, of protons that are, where the electron shells are merged. We have to look at what they're doing in a beamline. I accelerated ions when I was at AMD. In fact, I was in charge of what is called an implanter. And what it is a beamline where you create a species such as boron or phosphorus. You ionize it, whatever that is, right? You take an electron out of it. That's the explanation they've got. That's the easy one. What we're saying is, they have these threads spinning around them, right, in a certain way. And now you can manipulate those threads with magnets. Because what are magnets? Again, the spinning of magnetic threads, okay? And so what you have is spinning threads here. You have an atom that's got its electrons, threads also spinning, and so now you can manipulate that physically along the beamline. Now you can accelerate that atom because you have a physical interaction between the magnets on the sides that form the walls of the beamline and the atoms that are going through there. So what we need to figure out is which of it is it? Are we having a single proton moving along the beamline, right? Like a bead on an abacus, right, that you slide it? Or are we having a whole row of merged electron shells that reach all the way to the chamber where you're going to do your analysis? And that's, I ponder both scenarios, by the way, because I try to get to the bottom of that as well. But I can only theorize as much as anybody else once you know the basics of the rope model and, come up with your own theory. Maybe there's another theory. I don't know. Those are the ones that I come up with. Okay? I can't tell you I've got an exact theory that I can sink my teeth into for those processes, because I'm still thinking about them. I'm trying to visualize what could be happening in there, especially after I ran, implanters for such a long time, accelerators. I can't tell you for sure this is it. No, I'm theorizing, okay, still, okay? I don't believe in my theories. I just try to understand them. Okay, in a rope model, the proton cannot exist outside the atom, right? No, as far as I know, as far as I imagine the way I visualize it, okay? There cannot be a naked proton, okay? Proton is always covered with, it's never in shame, naked shame. It's always covered by an electron balloon, okay? So that's the way I visualize it. Maybe you can find some kind of scenario where it lost completely its skin. I cannot imagine that, okay? I can imagine threads moving around at a certain distance, but not completely lose its clothes, the proton. Yeah, I don't think you would find, if you were Atom Man or God or whoever, you go down there deep into an atom, will you find a proton star, just the single threads in every direction, gazillions of them, and no electron shell encapsulating them? I don't think so. I don't think that scenario is possible. Okay, but that's, again, these are things you hypothesize and say, what if? And I guess you're just as intelligent as me to figure it out once you know the situation. Okay, so everybody can try to reason this out and reach their own conclusion. Maybe you come up with a new theory. Who knows? Okay. Okay, folks, I'm kind of losing my voice, so I'll see you next week. And hopefully you start thinking about time a little bit, okay? What is time? No such monster. There is no such thing as the time out there. It doesn't exist because only objects can exist. That's the bottom line on that one. And time, you cannot have a slice of time. Time requires at least two slices, two frames in a Universal movie. You can't do it